dashboard for build, test, and publish the latest version of software for source control to all of our products. Obviously, that means different things in different people's spaces, but fundamentally, this is going to transform how we do everything, and it's one of the keys to us winning. And I think if you look at our priorities here, you can see it touches all of our priorities. So it's also a great example for us to track our progress on the priorities over time and really pull the entire organization forward on those 4 pillars. Next slide. I've been personally quite impressed with how quickly you all are moving on the incredible amount of work and dedication happening in this space. And I want to highlight some of the big wins I've seen. Today, you're going to see how our own innovations have led to velocity and speed, as well as cost savings and higher quality output. So before I steal too much of the thunder, I'll tote it over to the experts. We're going to start with Tony Corsetti. He's going to talk through the mechatronic infrastructures team's race to do a nightly full regression testing. So Tony, over to you.
Thanks, Dave. I'm excited to represent the mechatronic infrastructure team, sharing huge accomplishment that the team has done here recently to dramatically improve speed and quality. So first, a quick explanation of what mechatronic infrastructure is. Every car truck that rolls off the line has dozens of microcontroller-based devices that basically use sensors and actuators to control electromechanical systems to do things like stop, go, and turn. Each one of these has deeply embedded software that sits below the application that handles things like flash programming, communicating over serial networks, booting up, those sorts of things. We call this the mechatronic infrastructure software. It's kind of like the foundation of a house. It has to get finished very early because everything else sits on top of it, and it's really safety critical, so it has to have bulletproof quality. So let's talk a little bit about speed and quality and the old way versus the new way. The old way is a lot of silver box level system testing at major milestones, really resource intensive, so it takes a lot of people and a lot of physical benches, and often takes months to perform a full sequence. And because it takes so long and requires so many resources, it can really only happen at major milestones. And then there's this really long latency between finding an issue and then going back and figuring out what the defect is and resolving the defect and then doing another loop. So as we transform our organization going forward, we have to make CI/CD real, and we have to invest in our infrastructure. So for SDV2, we have a new way. SDV2 is more than just a software and electrical architecture. There's also this whole new development process that goes along with it. Integrated with our CI/CD pipeline, highly automated for both physical benches and our virtual testing in the cloud. Having that virtual cloud testing allows us to be basically infinitely scalable, so we can get the total regression suite down to hours, not months. And together, what this gets us when you put it all together is this daily build, test, triage, fix cycle. So going forward, we're going to run every test we have on every software build every night. And this means that quality defects show up on our dashboard first thing in the morning before we take that first sip of coffee. We can see what the defects are and immediately address them. So things that used to take several months the old way now happen overnight. So it's literally 100 times faster. And this fundamentally changes what we do. So we had our first opportunity here recently to apply the new way in our so-called New Year's push. It's something that started in late September and went through the first week of January to get our first SDV2 mechatronic infrastructure software out there. We were fundamentally committed to getting to that deadline with nightly automated regression testing for the first set of builds and the most important test steps. So by the first week of January, we had over 10,000 test steps running across 10 builds every night. And now that we've gotten to that scale in infrastructure, here early this year, we've set our sights on expanding the capability across all the product areas in the embedded application space. So this is a really big deal. We're super proud of the team and what they've accomplished. Such a big deal that Mary and Mark stopped by to visit our lab, and they signed our graffiti wall of automated test numbers. So thanks to the team for this great feat. And with that, I'll turn it over to Brady.
Thanks, Tony. Hi, everyone. So I want to talk a little bit today about all of the steps that everyone takes in their day-to-day work. There's a lot of different steps on the road, from an idea or a discovery of a bug to getting that software fix out to a vehicle or out to a cloud service. And one of the key drivers of quality is our ability to iterate on our software as fast and as smooth as possible. our current software iteration cycle is pretty long, and it can take a while for us to get fix or change or feature out to a vehicle for testing or out to a cloud service. So infrastructure engineering as an organization, we have teams that touch every aspect of your day-to-day workflow. But I want to focus today specifically on the software delivery team. Software delivery team works to build and provide the tools, services, and workflows that you work with every day, from your management of work in the bug tracking tool, your pull requests, build and test. We recently formed the build and integration team as part of the software delivery organization, where we consolidated together all the DevOps teams so we can build one common platform and bring everyone together to make sure that we are simplifying the workflow process every day. One of the main areas that we're trying to focus is by consolidating and making tools consistent across every engineer's life. So if we can make one workflow, one process work for everyone, when we improve and simplify that workflow, it helps everyone across the organization. We're already seeing great progress on that path. We've started migrating, we are in the very far along the road of migrating everyone to using Jira. So that provides one large centralized place for all of our bug tracking and project management. We've also moved over 100,000 repositories into GitHub as our central location for source code management. And on the server side, we've been building the Atmos platform. That is a central and consistent way for us to deliver services to Azure and to other clouds. And we have almost 300 services in production in Atmos right now. So we've got a lot more progress to go though. Right now, we still have a fairly slow iteration cycle. And the more iterations we can make, the better the quality of our products. So we need to work to identify where our daily workflows slow and have friction, and how we can improve that. The software delivery team and infrastructure engineering team are here to help make that happen for everyone. So with that, I will pass it on to Jeff, who's going to talk about quality work.
Thank you, Fraser. Hey everyone, I'm Jeff Olson. I lead a vehicle software quality organization in Abdul Bazi's organization. Today I'm going to walk you through how we're taking automation enablers and applying them to a vehicle to maximize the efficiency and value of that asset. But first, I thought it'd be meaningful for a quick overview of the vehicle development process. So it's a lengthy process. As you can see, there's a timeline here. This is the GVDP 7.0. And what we'll focus in on here towards the end is the maximum exposure. When we start to get the exposure of the software at scale happens 8 weeks before we ship a vehicle to customers. So this is where there's company vehicles that are assigned to drivers. They're reporting issues, they're testing software, and we're curing things and fixing things and getting a measure of how the software is actually doing. But there's some problems with that. It's subjective. So it relies on humans to notice that there's an issue, to report an issue. Then someone's got to take the issue from that system, traverse it all the way back to the development team. When you look at how many hands an issue actually touches from the time someone's reported it to getting it back to a developer and then code and then releasing the software again, it's an extremely inefficient feedback loop. It's also non-deterministic. Humans are random. I don't do the same thing every day, which is a good thing for finding issues, but when we're trying to get a measure of quality, that can be a bad thing from a baseline perspective. In the majority of time, a vehicle spends its life as idle. So when you think about yourself on a daily flow, you drive to work, drive home, might go to the store, pick the kids up, drop them off from school, and really that vehicle is getting used the same way over and over again. So what can we do about that? We have come up with a solution to take our automation enablers in a non-invasive way and apply them to the CTF vehicle. The CTF vehicle in its average life is idle for an hour and a half a day. So how can we leverage the other 22 and a half hours and extract value out of that? Well, in comes a Raspberry Pi, an Ethernet cable, a webcam, and a power bank. And what this enables us to do, powered by Autobot, is pass out these devices to drivers. They plug in, They position the camera pointed at the display. The algorithms already learn where the display is, make sure that it's working properly. They hit a button when they park and it's safe to test. I come to work, hit enable testing. My vehicle is no longer sitting idle for 8 to 9 hours. It's now running cycles. And so what we found is by just passing these out to our super users, we've increased the exposure and usage of our assets by 5 times, which is significant. So we're tightening the feedback loop, we're getting quality faster, we're developing a regression suite where every software release, every time we develop a VESCOM, we push it out, we can run it, and we can know within a day whether or not we've got a package that's worth exposing to other people. So what's next? So we are going to increase scale. Currently, we're doing this in super users. We want to have one of these devices in as many vehicles as possible, and which just means lots more issues, better quality software. We've also want to increase our capability in production units. So we've had a great partnership with Mike Hanley and his new organization. It truly is yes and. So we approached him and said, hey, we're pretty locked down in production controllers. How can we take all these great things we're doing in development and enable them in a secure way? And we're working with them and we're moving very fast to do that. We're also expanding our test suites, areas that we're focusing in on across different parts of the vehicle. Infotainment was one that we've started with, then we've expanded out to body, mechatronics, etc. And then also the more important thing is taking everything that Tony and Fraser reviewed, and we're going to push this back